Awesome. Well, thank you all for your patience. I'm sorry we're a half hour late. I will make sure to get you out the door so you can get to the raffle. I don't want to get in the way of that. But I'm Nick Karpinski. I'm the dev lead for the Visual Studio Profiler team. And my team's mission is to really democratize profiling and performance. We want absolutely everyone to be able to use the tools that we're making to go and make your software faster, make your customers happier, and reduce your overall compute spend. And so today I want to show you basically how you can use those tools on some real world .NET code. And with any luck, we are going to optimize an open source library, and hopefully they'll accept our PRs. I'm almost scared to show this slide. If you get a chance, please do the session survey. Keep in mind, I was not the one that blew the breaker, but I am very interested in hearing what you have to say on this. This really kind of influences the material that I show when I present. And so let's do a quick poll. Now that you all have been stuck in here, who's ready for the talk? Hey, cool. Of everyone in the room, who here has used the Visual Studio Profiler before? Okay, actually, I'm surprised. Looks like it's more than 50%. And I'll be honest, I don't always get 50%. Who here has used benchmark.net before? Okay, couple. Of those of you that have used benchmark.net before, who's used the Visual Studio Profiler integration with benchmark.net? No, well, a little bit, okay. So you might have seen it if you saw the keynote yesterday, so a little bit. The what?
The integration is a new thing.
The integration is a new thing, and we're gonna show it off today. And who here has used Copilot before? Hey, that's awesome. Okay, so I wanna show some of the integration that we can do with that. But before I get into it too much, I wanna kind of set the stage for why is it that we profile and why don't we? And obviously, one of the reasons why we profile is our customers expect it. They want fast software and we should be able to give that to them. In terms of why we might not want to, I get it. Features are typically more important than performance work. And it's just a fact of life. I would argue you should try and treat performance as a feature, and you should really try and do that because your customers will love you for it. If you heard Mads during the keynote yesterday, we've been doing that with the next version of Visual Studio. People who have used it, they're really excited by it, and we really are trying to live this. Why do we profile? Because without data, you're just refactoring. If you don't have data that shows you the difference, even if it's just a stopwatch that says, here's how long it took from beginning to end, before I made the edit and after the edit, you're just refactoring. And the profiling tools in Visual Studio can really help you narrow in what you should be doing and show you that data. One of the reasons why you might not be profiling, because you can hide poor performance in async code. I've never heard someone explicitly say that, but I've seen all too often, it's like, oh, this part's slow. What do? Task.run. Oh, wait. It's like, I've even done it. I am guilty of it. But that's not the experience we want to build for our customers. Because while the UI might stay responsive, we might still be able to process requests. That just leaves a really bad experience for our users. Why else do we profile? Because it saves money on compute spend. I know Azure is expensive. I hope you're all using it. I want that stock price to go up. But at the end of the day, I realize we all have budgets. And sometimes just a little bit of profiling can really help you reduce that impact. And then lastly, why don't we profile? Because it's hard. I've been there. I help write the tools and I think it's hard. But I want to show you today with the profiler and with our new Copilot profiler agent, it doesn't have to be. And so I know this is a bit of an eye chart. Hopefully you can see it in the back. But this is what I think of when I say the canonical performance improvement pipeline. Basically, you want to figure out, do you know what your issue is? If you don't know what your issue is, you run the profiler. It gives you a report at the end. You know what your issue is. Once you know what your issue is, do you have a benchmark that exercises that issue and that shows you that issue? If you don't, writing a benchmark is such a great way to really narrow in on something and give you a reproducible thing. You can still do performance improvement without it. It just becomes a lot harder. We're going to show you examples today where we use benchmark.net to be able to reproduce performance problems and then fix them and then see the impact of that. Along with benchmarks, you can also use unit tests. There's some caveats with it, and Harshada in the next section is actually going to show you how you can do that. And then once you have your benchmark, you kind of fall into this optimization loop. And this is where the whole measure twice, optimize once comes. You make a measurement, you get your baseline, then you go, you edit your code, and the next thing you do is you go and you run it again and you validate. Did I improve things? Did I make them worse? And if you improve things, cool. Success, celebrate, eat some cake. If you didn't, then you go back to the optimization loop, or you go all the way back to the beginning. Let's figure out what to do. And so the new Copilot Profiler agent does all of this, and it guides you through this. And so with that, let's hop on to the demos. So, CSV helper. So for this talk, I went to NuGet.org and I was browsing. If you click on the package statistics, you can see what are the most popular packages that are on NuGet. And there's all these different packages, but in the top 100, there is the CSV helper package. And this project is basically helps you parse and write CSV files in .NET. It's a great little project, and so what I did is I went to the source repository, I opened it up, I cloned it in Visual Studio, and I'm here. And if you look in this project, there is the CSV helper benchmarks, and actually those were written by yours truly for my last talk that I gave, where I did a performance improvement, and I want to show how with the new Profiler Copilot agent, you can do that today. And so in GitHub Copilot, I can talk to the profiler. In this case, I can also just say, run the hashtag enumerate records benchmark and optimize the memory of the code that it calls. And with any luck, Copilot automatically detects, hey, you're trying to do some performance optimization. I have an agent that's really good at doing that and helping you. Why don't you go ahead and use that? And so I can say confirm. It's going to start a new conversation with our agent. And you can see to fulfill your request, I'm going to run the CSV benchmarks, enumerate records benchmark to establish a memory usage baseline. Again, that measure twice, optimize once, you're getting your baseline. It's going to analyze the benchmark and its code path for memory optimization opportunities. So if you saw the keynote yesterday, I said, hey, optimize my code. I use the CPU usage tool. Now I'm saying I want to do that, but I want to do it for memory. And so it knows, hey, there's a different tool in the profiler for that. It's going to analyze the benchmark, look for opportunities, suggest, implement memory optimizations for relevant code, and rerun the benchmark to verify improvements. And if I expand this, you can see it's going ahead and it's running this. For those of you that have used benchmark.net, someone had said like, hey, the profiler integration is a new thing. It is. The profiler agent will automatically add in NuGet packages. It'll give you a chance to actually confirm that. I previously did this so that the demo is a little bit faster. But there's this new NuGet package of Microsoft Visual Studio, Diagnostics Hub, benchmark.net diagnosers. And what this does is this lets the profiler attach to your benchmarks while your benchmarks are running, and it lets us extract data from it. So you get your normal diag session report at the end. The other thing, while we're waiting for those benchmarks to run, that our profiler agent does is it kind of adjusts your main method for benchmarking. And so what it did here is it went ahead and it added in our .NET Object Allocation Diagnoser. And so for benchmark.net, diagnosers are, again, that thing that lets different tools attach to it and extract information. There's an event pipe one, there's one for concurrency visualizer, there is the Visual Studio Profiler one as well. And then along with that, the agent knows we need this VS Diagnostics configuration environment variable thing. And then along with that, it also limited the iteration count and the warm-up count for allocations, because allocations are typically pretty deterministic. Like you're allocating memory, and you do another run, you're gonna allocate ideally the same amount of memory, whereas like CPU usage is very variable. Like, different things could be happening. You could be watching a YouTube video while your benchmarks are going, and that's gonna skew your results. And so benchmark.net tries its best to run the number of iterations that it needs to get statistically significant data. And so with allocations, because we don't need to worry about that, we automatically kind of try and limit that for you. And so with the result that I've run, we get a fresh new report, and it shows some top insights, and the profiler has already started to dig through this, and it's digging through the code and trying to fix stuff already. And so the profiler agent today, like we talked about during the keynote, it's coming out in the next version of Visual Studio. So it's not available to you yet, but I want to show you all the different things that you can do that the profiler agent is actually doing behind the scenes, so you have an idea of what it's doing. So once you get access to that profiler agent, you know what it's doing and you'll know how to better work with it. And so the first thing is our top insights page. This has different insights that we have basically pre-programmed rules to look over your trace and say like, hey, if you're doing these things, these are typically bad things, you should just go ahead and fix them. And so you can see the very first one we have is you had these zero length arrays and they exceeded an allocation threshold of 100. You can click learn more. We will take you to some beautiful documentation that'll tell you the cause, the problem, exactly what's happening. But you don't need that because you got me here to explain that to you. And the problem with the zero length array allocation is it's an array allocation that holds exactly 0 elements. But how many bytes does it count out on the heap? Anyone? 24 bytes. And so for every zero length array allocation that you're doing, you're throwing away 24 bytes. And you're like, Nick, that's not a whole lot of stuff that we're throwing away. Well, if I click the investigate, during that one benchmark run, we allocated 640,000 empty type arrays that accounted for 15 megabytes worth of garbage. That is an incredible amount of garbage. And this is in a super popular open source repository. No shade. When I show you the actual fix, you're gonna be like, yeah, Autocode reviewed that. That looks great. I know I've done it too. And so we can go ahead, we can find that by clicking on by double clicking on the allocation in the allocation view. And profiler agent is getting ahead of me. It's already implemented a fix and is trying to recheck its work. I can see most of the allocations are happening in this anonymous method. I can right click on that. I can go to the source file and I can see like, hey, this is actually occurring here. But if you look at the code, for those in the back, you're really probably gonna have to squint. I'm sorry, I meant to have it on this huge display. But if you look at this code, you don't really see where there's actually allocating an array. And I know, after much investigation, it's actually in the create instance function, because that create instance function was inlined, which is actually in the get function, which was inlined, which is in the get args type, which if you look at the code, you can see Copilot's already gone ahead and made an edit. In here, it was getting passed in an args, and it's trying to identify what is the type of each of those arguments that's being passed in. But the check that was happening was, there was no check. It was saying, what is the length of the array that's being passed in? I, of course, have to create a new array to stuff all my results in, add the types in, and return it out. And so what happens is we're trying to satisfy some sort of API, and we're creating a ton of garbage. And so you can see the fix that Copilot did. It said, oh, hey, you're doing this silly thing. It already identified where it inlined and then dug in. And you can see it created this static empty type array so that if the length of the arguments is 0, we just go ahead and return that. And so Copilot's already done that. We zip through this a little bit. Allocated memory per run has decreased from 381 kilobytes to 333 kilobytes. Again, it doesn't seem like a huge amount of memory, but this stuff really adds up. And what I want to show is in our collections tab, we actually show you these are all the different GCs that occurred during that benchmark. And we have all the information, like what GC number was it, what generation was it, the type of GC it was, the GC reason, the pause duration. And if I sort by the GC reason, you can see there's a bunch of these allocation small reasons, and 1, 2, 3, 4, 5, 6 of them actually occurred, each of them about 100 to 150 milliseconds. So it's close to 1 second worth of GC pause because of small allocations. And if I click on that, we show this cute little pie chart that gets animated in, and you can see that empty type array allocation was one of the major contributors to that GC. And by implementing that one small fix, we've actually gone and we've reduced the allocations there. And so Copilot has automatically gone and done that. I could have done all of that myself. The tools are available to you today. Copilot just makes it a lot easier. And then additionally, what's really interesting is after it ran, it checked its work, we still have more zero length array allocations. And if I click on and investigate that, you can see we have more type allocations. And so those are happening in this should use converter. And so if I was interested in it, I could say it's already called out, like it looks like the next step to address allocations is in this has parameter list constructor. Please fix those as well. And then the profiler agent will go ahead and identify that. It's located that, it's gone ahead and it's fixed it. And again, you can do this all the same work. You can go through, you can dig through the allocations, and then you can find that backtrace. So I could click on here, I could right click and I could say, oh, I want to go to the source file. This has parameter list constructor was probably inlined, and sure enough, Copilot beat me to it again. Where it was checking for a parameter list constructor, you can see every time they're actually allocating a junk array. Copilot has gone ahead and it said, you know, I'm going to use the static one. You could have also just done array.empty, but either way, this is an acceptable fix. And again, another way to reduce those allocations. And so, like I said, it has an impact on the amount of GCs that are occurring. And when I added in the benchmark for it, along with the fix, I actually found that removing that one junk array allocation improved that benchmark by 14% wall clock time. So it's a quick 14% fix off of a tiny little change that if I looked at it, like I saw that in code review, I'd be like, yep, that looks great, makes total sense. And so it just goes to show, like, use the tools, you run the tools are gonna point out different things to you. And with any luck, looks like Copilot's still running its stuff. It's going ahead, it's doing more optimizations. And so I also wanna point out one other cool optimization you can do with this tool. I tried to get it working for this demo, but the fix ended up being a little bit more involved. But we have these different views. The allocations view is my absolute favorite view. We actually built this view specifically for Stephen Tobe. If you know who he is, the big performance guy, he lives in this view every single day. Okay. And one of the things that we added for him were these cute little icons that show you, is this a reference type or is this a value type? And the interesting thing about seeing value types here is that means you allocated a value type, which means it is getting boxed and getting put out on the heap. And the really interesting one here is this int32. So we allocated 640,000 ints in that benchmark, and that accounted for another 15 megabytes worth of allocations. And again, if we go back to our collections, we look at one of the small allocations, hey, sure enough, those boxed ints that are going out on the heap are actually causing problems, and they're causing more GCs to occur. And so I could double click on that. I could go to exactly where it is in the backtrace. Fortunately, my poor laptop is struggling because Copilot's doing work and I'm doing work. But you can see, looks like most of them are coming from this convert to string. If I go to the source file here, you can see convert from string on int32 converter. It implements some default type converter. So they're probably implementing an interface. I know this because I've kind of poked through this code a little bit. It gets text in, it does a try parse on the int, it gets the int out, and then it returns it. But the problem is you have this nullable object that it then gets cast to. And the only way that you can return that int as a nullable object is it gets boxed, it gets allocated, it gets shoved out on the heap, and then returned. And so that ends up being more junk that the GC has to go and fix. Now, I'm not saying you should always go and do unholy acts to never box or to never have these empty type array allocations, but the tools really highlight where these are occurring. And when you start seeing large numbers, it's a quick fix to go in there, implement them, and then make a pretty substantial change. And so Copilot finished up. Remaining zero length array allocations are now in system object. There's more zero length array allocations. I could keep digging at this indefinitely, but I know you guys all have a raffle to get to, so I will stop and we will move on to the next thing. So I'm gonna hit close tabs on this. We are going to throw away all of Copilot's beautiful work. I'm sorry, Copilot. And let's check out the CPU demo. Awesome. And so in the keynote yesterday and just now, you saw me kind of point Copilot at a benchmark and you were like, hey, Copilot agent, go fix this. A lot of times people are like, hey, I don't have benchmarks in my repository, or I don't have a benchmark for the thing that I want to benchmark. Makes perfect sense. The other cool thing you can do with the new profiler agent is I can say, help me write a benchmark for the write records method. And you can see Copilot kind of goes to town. It's searching for the write records method in the workspace. It's locating it. It's reviewing any existing benchmarks in the benchmarks project to try and stay consistent with the style. It's proposing a new benchmark and validating the benchmark. It's gone ahead and done some tasks, and would you like to proceed with benchmark creation, or yes? So many times you've got to just, yep, keep going, keep going. Kind of like a very eager intern. You're like, yep, doing great, keep her going. So it's creating the benchmark, it's searching for more stuff. Project analyzed. Cool. So it's gone ahead, it's created a new benchmark for me. It checked for any errors, it's already executing a build, making sure that that's good. Build is up to date. I'm gonna say keep. And you can see it's done all the good benchmarking stuff that I would expect out of anyone who's writing a benchmark for me. It's made use of the global setup so that it can try and do the things that we're not interested in benchmarking, like going ahead and creating all the simple records outside of the benchmark. It's got to clean up, so it's properly cleaning up. And then you can see it uses this memory stream, and it clears out the memory stream by setting the position and the length, creates a new stream writer, creates a new CSV writer, and then writes all the records to it and then flushes it out. And so just a pretty standard, simple benchmark that I would expect. One of the cool things that I like to do is then I like to go and customize. I can hit Alt// and I can talk to Copilot inline as well. And I can say things like, add a second int and string field to this class, update the global write records, global setup method accordingly. And sure enough, it goes and it adds it in. It's gone ahead, it's created a new ID2 and name2. Again, something super easy that I can do. Copilot just really takes the toil out of it. And so I can focus in on doing the optimizations and providing the value that I'm really good at. And Copilot can just kind of be my helper in that. And so now that I have this benchmark, let's see if we can go ahead and we can optimize this. So let's say at Profiler, actually, I want to do a new chat. Different people have different things that they do. Some people do all their chat in one big giant thread. When I like to keep all of the stuff that's related to a single task in one thread, and then when I start off a new task, it seems to me that it's better to kick off a new chat thread with Copilot, just because I'm not using up all of the tokens that are available to me on the creating the benchmark task, which I've already done, I've already completed, I've accepted that. I don't need it. And so in my new chat, I'm gonna say at Profiler, run the hashtag write records benchmark and optimize the code that it calls. So exactly what you saw yesterday in the keynote, except we're actually optimizing some pretty real .NET code here. We also have this new optimize code lens you can click. So you could click that and you could click optimize with Copilot. Just trying to get more of those entry points in, so it just makes it easier for you to author your benchmarks and then go ahead and analyze the benchmarks. And so again, in that canonical benchmarking loop, Copilot's done a good job. It's saying, I'm gonna go run that benchmark. I'm gonna establish that baseline. I'm gonna analyze the results from that. I'm gonna edit the code. And then I'm going to propose and apply those optimizations and rerun the benchmark again to validate the performance improvements. And so it has already run. The benchmark UI pops up. I switch over to my CPU usage tool and I get all of the good information that you would expect out of the CPU usage tool. Copilot's already digging in with its analysis. It's saying the write records method completes in approximately 4.2 milliseconds. Most of the time is spent in dynamic delegate invocation, expression compilation, and quoting logic. It gives me some main bottlenecks. And if I look at our top functions, expression compilation, some external call, sure enough, it's there. Multicast delegate invocation. I have never, until I did this performance improvement, I have never done multicast delegate invocation myself. So I actually, as we go through the optimization, I had to ask Copilot, like, what the hell is going on? I've never seen this before. And it taught me something new, which is really exciting. And then you can see that in the hot path as well. And so again, I want to show you what's available in the tools today and how you would do that sort of performance investigation. But then again, Copilot is going to do this and it's going to take care of the toil for you. And so I can click on this multicast delegate invocation and you can see it shows up in our call tree. I can navigate the different views of the call tree. So I just went up one record or one level in the stack so I can see the thing that's actually doing that dynamic multicast delegate invocation. It looks like it's happening as part of some enumerator type that it has. And then it's also happening in this write record. I have no idea how to go and optimize this. I just know that, hey, it's taking a bunch of time. While we're here, I just want to point out one other really interesting view. Another view I love is our flame chart view. It just kind of gives you this nice visual representation of where time is being spent. The time equates to the size of the box. And sure enough, you can see that multicast delegate is in fact expensive in here. And so with that, I could go through, I could dig in here, much like the allocation tool, I could right click on a node and I could say like, hey, I want to go and investigate, see where that is done in source code, and I want to make some edits and run, but Copilot's going to take that toil out for me. And so let's close this. And Copilot's asking, would you like to focus optimization on delegate creation, quoting logic, or both? Please confirm your preferred area. I'm going to say, please proceed with the delegate invocation optimization. We can see what Copilot's gonna do. I'll be completely honest, this is the other one Copilot's been very consistent on. This is about an 80% success rate, so you might see me lose my sanity as I try and wrangle an LLM, but hopefully it's gonna figure it out. So the main bottleneck is in repeated compilation and invocation of the delegates. Next optimization opportunity is reduce the overhead of invoking multiple delegates per record. Currently, it creates a separate delegate for each member and then combines them. It plans out the optimization. It's gone ahead and it's made the edit. And sure enough, it's done the right one. It just removed comments. I don't know why Copilot really hates comments. It seems to remove them all the time for me. We're working on prompting that back in. But what's happening here, and this is the optimization that I had no clue what it's doing. I don't know this library very well. I've contributed to it, but I'll be honest, I've contributed to it with the tools. But looking at it, what's actually happening is Copilot switched from holding this list of action T to holding a list of expressions. And where it was calling expression.compile, it was just adding the expression to the list. And then it does the same down here where it was doing an expression compile, except it was, again, adding it to the list. And then at the end, what it was doing was it was calling this combine delegates method and then returning that, or if there were no delegates, or if combined delegates returned a null, it returned an empty action. Copilot instead has said, I want to say expression block and create a new expression block based off of all those other expressions that I have, and then I want to do a single compile. And sure enough, it got that right. I'm going to say keep. Sometimes this happens. I've fixed the problem. Please continue validating the benchmark. And so Copilot's going to go off in the background. I'm going to explain the expression compilation thing as much as I can. So what was happening before is it was creating a new Lambda for every single field in the record. So if you're thinking of the CSV file, think of a single row. We have a field that each field is separated by a comma. It was using a different Lambda action to parse each single element in there. What Copilot reasoned about was, hey, we don't have to do that. Instead of parsing each one separately and doing that multicast delegate. So the multicast delegate is, I have a new row record, invoke all these different things to parse all of this different stuff it into my record type and return it to the user. Copilot said, I can do that with a single action. So I'm not invoking all those times and I'm only compiling the one thing, one single block. And if anyone understands how that all works and what I just explained, you're way smarter than me, because it took me 20, 30 minutes of chatting with Copilot to be like, oh, hey, this really is a true optimization. I get it. I see what it's doing.
So you expect the benchmark now to be better, right?
Question was, you expect the benchmark to be better now, correct? And yes, I expect it to be better. We will see if the numbers are happening. I've found that sometimes when I'm live presenting, sometimes it's 20% better, sometimes it's 2% better, and it's a little sad. But while we're waiting for that, I do have a new PR out on this repository. I ran it a couple of different times, and in fact, doing this one optimization resulted in making this about 15% faster. And so you can see the before, you can see the after in the PR, and it made it faster. I did put a little disclaimer here. I talked about this just very briefly initially, which is benchmark.net tries its best to capture statistically significant data. So it doesn't do a set number of iterations. It takes your benchmark and it runs it over and over and over again until the standard deviation and error gets minimized. So it might run it 10 times, it might run it 100 times. When you attach the profiler to it, that means you're getting the CPU samples while that benchmark is running. And so what happens is in this after, there's actually this very first stream writer write, we have 13,000 samples, but in the before, it ran it a couple of times and it got statistically significant data. And so you can see the top hitting function only has 4,000 samples. So when you're looking at the CPU traces from the benchmark.net benchmarks, typically you don't want to look at the exact number of samples. You want to look at that percentage and kind of adjust accordingly there. The one area where samples is good to look at is whatever you're optimizing, you want to make sure you at least have, rule of thumb is kind of 100 samples there to make sure it's statistically significant. Because sampling occurs every millisecond in the profiler. And so if you only have one or two, you were there maybe 1 or 2 milliseconds and you might have got there by chance. Whereas once you get to about 100, you're good to go.
Question.
Yep.
So are there unit tests around this to verify?
Haha, I love it. You're doing my talk for me. The question was, are there unit tests to verify? And yes, that's a very good call out, and I'm gonna talk about that in a second. So Copilot says the right benchmark now completes in about 3.4 milliseconds, down from 4.2, a significant performance improvement. Thank you, Copilot. Delegate compilation overhead has decreased, confirming the optimization is effective. The next largest bottleneck is in the quoting logic and type conversion. And if you remember back from that allocation thing that we did, we saw the type conversion in the allocation stuff as well. Remember, it was allocating those ints. That would actually probably be a good improvement. It's something I'm working on. I wasn't able to get it to work for this demo. But there was a question about unit tests for this. Yes, there's a whole suite of unit tests. I'm not gonna sit here and make you wait through the unit tests, but I did run them. And if we look at it, look at the files that were changed, one thing that Copilot did miss was at the end, there was that combined delegates where if combined delegates returned a null, it returned an empty action. There is a case where you get a record in CSV helper that has no fields, AKA basically a blank line. And with the original thing where it said, hey, expression block compile, if there's no records in there, you get an exception. There's a unit test for it. It caught it, which was super exciting. So all I did is I said, hey, if we don't have any expressions in there, just return a new empty action that does nothing. And again, this is a pointless allocation. So ideally, I would want to go and fix this as well, but I'm improving the code already, and I'm fulfilling the API that I need here. And so with that, we're getting close. We're not at raffle time yet though, so don't worry. I wanna give a couple of takeaways real quick, and then I'll open it up for questions. The takeaways though is build in the right automation. Unit tests are just as important as benchmarks. Because otherwise I would have screwed up with this change in Copilot, and I would have been none the wiser because I don't know about this code base. The cool thing is Copilot and the Profiler agent can really help with this. It can help you make those benchmarks. It can help you make those unit tests so you can feel confident in the changes that you're making. The next thing, treat performance as a feature. Your customers will thank you. Mads had proof of it during the keynote. We've been working really hard on performance for the next version of Visual Studio. Everyone that's used it so far has noticed how much faster it was. I don't know if you noticed, but as I've been doing stuff on my laptop here, I feel confident in doing live demos. The Profiler's been nice and fast. Visual Studio's been nice and fast. I'd love to see you all do that to your code as well. And then lastly, remember, it's the measure, optimize, measure. If you're not measuring, you're not optimizing, you're refactoring. It's super, super important to get that data so that you know you're actually improving stuff. Whether that is just using a stopwatch timer, it works, but we got much better tools that are going to pinpoint and show you exactly what you need to do and where you need to make those optimizations. And tests. And so with that, I'll open it up for Q&A. Thank you so much. Again, sorry about the technical problems. Sorry I had to rush through that. Yes.
Which is the Buzzard iterate, so
I'm going to give you this so that they can capture it on the recording.
Thank you. So the the agent recommends an improvement. So first you benchmark first.
Yep.
Before the improvement, then the agent recommends an improvement. You verify it, you accept, and then it runs a benchmark again.
Yep.
Can you accept it ahead of time and say, hey, please run with whatever you like and verify the improvement? If benchmark goes down, go redo the task differently.
Yeah, so the question was very focused around the actual optimization loop where the agent is running the benchmark, it's doing the edit, then you saw me hit accept, I kept that, and then it ran it. It will automatically run most of the time. Sometimes it'll pause and ask you to accept. It has a temporary file set up so that it will compile its changes in and then can run it. So you don't have to accept it. We are kind of fighting it a little bit because sometimes it'll be like, oh, hey, I didn't improve it, or I made things worse, and it forgets to revert the changes that it did. So I like to stay in control. And so that's why a lot of times, like during the keynote, I didn't just say like, yes, continue with optimizations. I said, what optimizations can we do? And I can have more of a conversation with it. And we're working to make sure that it kind of stops at those spots so that you have control over it.
Do we capture the benchmark results when we check in our code, or do we exclude those? What's the best practice there?
Yeah, so the question was around what's the best practice for capturing the results? Do you exclude it or do you not? I would say exclude it. The benchmarks are only valid on your machine in that environment. And so moving over to someone else's machine, not valid. When we capture the benchmarks, we actually put the benchmarks in the output folder. And so I have all those diag sessions. It has all that profiling data for it, has the PDBs, and it has how long each benchmark took. It's really only valid for my machine. We're looking at, how could we create some sort of PR setup automation for it, but it's a very tricky problem.